Question 44. Part A, x is 2t squared, y is t cubed, dx dt is 4t, dy dt is 3t squared, dt dx then is 1 over 4t. Okay, so then you do dy dx using the chain rules, dy on the top, dx on the bottom. So you've got 3t squared times 1 over 4t. Okay, t's cancel. Okay, so you end up having 3t over 4. So then at p, it says in the question your parameter is equal to little p. So dy dx equals to 3 little p over 4. X will equal 2p squared. Y will equal p cubed. Okay, so then we sub it in. Okay. Y minus then p cubed equals 3p over 4 x minus x1, which is 2p squared. Okay, so there the equation of the tangent is asking for. So if I take this up here, 4y minus 4p cubed equals 3px minus 6p cubed. Okay. Then let's simplify this. 3px minus 2p cubed is exactly what they're asking for then in part A. Alright, so in part B it says the tangent to C at the point P intersects C again, right? So tangent at C, it seems to intersect this curve again at the point Q. Given that P equals 3, show that Q satisfies this equation and determine the value of Q. Okay, well, they're telling us that P is equal to 3. If that's the case, using this, you've got 4y equals 3 times 3x minus 2 times 3 cubed. So 4y equals 9x minus 54. Okay. So that's what we've got there when they say that P is equal to 3. But then also it says, look, this tangent goes through this point. Okay, so if it goes through this point Q, we can say that this point Q must satisfy this tangent equation here. Okay, so quite simply, we could say, look, Q must satisfy tangent equation. Okay, Q must satisfy the tangent equation. So, in other words, 2q squared, q cubed must satisfy what we just established. So you just sub it in there, right? 4q cubed equals 9 times 2q squared minus 54. Okay, and then to get what they want, you just got to take everything to the left hand side and divide by 2. Okay, so we can say that divide by 2. And you get this. Okay, and then it says then determine the value of Q, right? So to determine the value of Q, you've got to be able to sort of solve this and factorize it. Okay, and when we factorize it, you've got to do the remainder theorem, haven't you? C1 factorization, because you've got a cubic here. So what we'll do, we'll set Q to be a value, okay, to work out one of the factors. Now you could set Q to be 1, minus 1, 2, minus 2, that's sort of sensible. But actually, I'm going to jump to an Q equals 3 straight away. I know Q equals 3 will probably work, okay, because if you remember earlier it said P was equal to 3, okay, and P equals to 3 is on this tangent then. Well, in that case then, because of the way this works, right, putting Q equals 3 will also work as well, okay, so we'll sort of explain that a bit more later. But, you know, you could try 1 first, minus 1, 2, minus 2, and one of them might work, right? But I know this one will work. And when you put it in, don't forget, one thing I haven't done yet is call it a function, right? Call it this. Okay, so I should have maybe written this first, doesn't matter. And then put in 3 here. So let's see if it works. You've got to check. Okay, so if you do that, yeah, indeed is 0. So therefore, q, because q equals 3, take the 3 over, q minus 3 is a factor. Okay, so what we do then is 2q cubed, factorize this. So that's one factor. The other factor then, obviously, because we want q cubed out, we're going to have 3 brackets on me because it's q cubed. You're going to have 3 factors. So there's one bracket there, 2 brackets here then. Well, when you multiply those 2 brackets, it'll give you a quadratic like this where a, b, c are constants. So let's work it out. Now, what we do to start with is equate the q cubed. So you've got 2 there. Q cubed here, well, it's q times aq squared. Q times aq squared is aq cubed. So that means 2 equals a. A will always equal that number there. Then equate the constants. You've got 27 here. Constants from here, well, you get the constant by doing minus 3 times c, right? That's the only way you can get a constant there, so it's minus 3c. So that means then 27 over minus 3 is equal to c. So c equals minus 9. And then to get the b then, let's equate the q squared. So you've got minus 9 there. Q squared here, well, you get q squared by doing q by b, so that's bq squared, so that's b. And also then the minus 3 times this, minus 3a. Okay, that's how you get the q squared. Now we know a is 2. So you got that, and then that implies then that b will equal to minus 3. Okay, so then, the last step then, you put the a, b and c in. Okay, and that equals, of course, what you've got up there. That equals what we're trying to factorize. So then, in here then, we're going to have 2 brackets. Okay, so I'm going to kind of have a guess at this. I think they're both 3 actually. Okay. And that's a plus then. Yeah, that's right. Okay, but factorize it the way you know. So then you've got q minus 3 equals 0. Or 2q plus 3 equals 0, or q minus 3 equals 0. Now you've got 2 of these occurring, so that means q equals 3, or 2q equals minus 3, which means q equals minus 3 over 2. Now q cannot equal 3, right? So in my result, this actually corresponds to p, doesn't it? So when you get q equals out to 3, right, you're going to have that, right? It will come out as 3 because it relates to the tangent, okay, where it's equal to 0, and it equals to 0 when the equation obviously satisfied for that value of p, when p equals 3. So the q equals 3 also corresponds here to p equals 3, right? So when it says q equals 3, q isn't really equals to 3, that corresponds to the value p equals 3. So this is the result we want here, okay, the other one. So q equals minus 3 over 2 is what we get.